Use your understanding of intermolecular forces to predict which of these compounds has the highest boiling point. So in terms of highest boiling point, I'm looking for something with a hydrogen bond that have the highest boiling point. Then I'd be looking for something that's polar, that's going to have dipole-dipole attractions. And then I'd be looking for van der Waals forces, something with no polar bonds within it, and therefore no dipole-dipole attractions, just van der Waals forces as the weakest and the lowest boiling point. So for hydrogen bonds, I'm looking for a hydrogen bonded to an oxygen, a fluorine or a nitrogen. I've got a hydrogen bonded to a fluorine here, so that's got hydrogen bonding, so that's my obvious choice. Hydrogen bonded to a Cl, well Cl is electronegative, so going to have a slight delta minus, and the H will have a slight delta plus, so that'll have polar dipole-dipole attractions between the bonds. Br is slightly electronegative, so it'd have a slight delta minus and a delta plus, and so would Hi. I is electronegative, so it'd have a slight delta minus and leave the H as delta plus. So B, C and D have all got dipole-dipole attractions, so medium sort of boiling points. HF has got the highest boiling point because it's got large delta plus and delta minus, large polar bonds between the H and the F, and therefore hydrogen bonds between the molecules, because the polar bond, the delta plus and delta minus, is so large because F is very electronegative compared to the H. So if you've got an H bonded to an F, an N or an O, you've got hydrogen bonding. The answer is A. Which type of bond is formed between N and B when a molecule of NH3 reacts with a molecule of BF3? Well, NH3, N is in group 5, it's got 5 electrons in its outer shell, it's got 3 bonding pairs, it's got a lone pair left over. After the 3 bonded pairs, 3 electrons go into the bonded pairs, because it's got in group 5 and got 5 electrons, it's got a spare pair of electrons, it's got a lone pair of electrons. The BF3 hasn't got any electrons left over because it's in group 3 and it's got 3 bonding pairs and they're all involved in bonding. So the nitrogen's got a lone pair. The boron, the B, hasn't got any electrons to put into a bond, so the nitrogen puts both electrons into the covalent bond. That's called a coordinate or a dative bond, where the covalent bond is set up, is created when both of the electrons come from one of the atoms rather than 2 atoms each putting 1 electron in each. Which of these atoms has the highest electronegativity? Well, I'm just looking down the list. You've got sodium and magnesium in group 1 and group 2 respectively, wanting to lose 1 electron and lose 2 electrons. Argon is in group 0, group 8, it's got a full outer shell, doesn't want to lose or gain any. Chlorine's in group 7, wants to gain 1 electron. So electronegativity is the power to withdraw electrons towards itself. So your answer is C. It wants to gain 1 electron, with it being in group 7, only needing 1 electron to fill its outer shell. Which of these atoms has the smallest number of neutrons? So what you do is, for neutrons, you take the mass number, the top number, and you take away the bottom number, the proton number, or the atomic number as it's sometimes called. You'll have to look these up. Top number, the mass number is 3 for hydrogen, it's 1 is the atomic number, so 3 minus 1 is 2. 4 take away 2, helium has got a proton number of 2, so 4 take away 2 is 2. Helium 5 take away 2 is 3. Lithium has got an atomic number or a proton number, whichever way you want to call it, of 3, so 4 take away 3 is 1, so your answer is D.